Hello everyone. Today we are going to revise the total syllabus of this week JEE mains examination. Okay. So in this syllabus, main concept, the difficult area, most of the important area, what is to be understood is that yesterday we started discussion and stopped. Suppose if two reactants are there. Okay. So reactant 1 plus reactant 2. Reactant 1 and reactant 2. These two react with each other to form some products. Some products are formed here. That point keep in mind. Now, in this chemical reaction, what we have to mainly understand is that the number of equivalents of first reactant, number of equivalents of okay reactant 1. So reactant 1 must be equal to number of equivalents of reactant 2. So I'm taking this one reactant 1 and this one as what reactant 2. So the number of equivalents of or number of gram equivalents of reactant 1 must be equal to what number of gram equivalents of reactant 2. So this point keep in mind. Okay, so I'm taking this one here. Gap I'm giving. So is equal to what now? Number of gram equivalents of reactant 2. And now here, now what mainly we have to understand is that now R1, R2, if you take R1, R2, number of equivalents of this one and R2 I'm taking. So number of what here reactants of first one and number of equivalents of second one. So now here first reactant and second reactant I'm taking. Now in this case, number of equivalents formula what? What is number of equivalents formula for any substance? Number of equivalents is equal to first thing what we have to understand normality, or first you take given weight of first reactant by what? Gram equivalent weight. Given weight by gram equivalent weight. Again, gram equivalent weight, how to calculate for different substances? Gram equivalent weight is equal to gram molecular weight by N factor. So gram equivalent weight of any substance is equal to gram molecular weight by N factor. We have to take it. N factor calculation we must know. N factor of H2SO4 is what? 2. N factor of NaOH is what? 1. N factor of different substances already we have discussed. So given weight by gram equivalent weight will give number of equivalents. And the same thing we use for this one here. So number of equivalents of this one is equal to what? Given weight by gram equivalent weight. Is that clear, ma? Now second formula, number of equivalents, second formula is what? Normality of first one into volume of first one. Normality of first reactant, volume of first reactant in liters. Remember, N1 into V1. That is equal to here. What we take? N1 into V1 in liters. That means what now? Volume of second reactant in liters we have taken. What volume of second reactant? Volume of second reactant we have taken here. So volume of first reactant is V1. Volume of second reactant is V2 here. So N1 into V1 is nothing but the product of normality and volume in liters is called what? Number of gram equivalents. Here also N2 V2 is what? N2 into V2 is called what? Number of equivalents, gram equivalents of second reactant. Okay. Next one. So these two must be equal. I told you, number of equivalents of first one is equal, number of equivalents second one. Now here N1 V1, here N2 V2. So N1 V1 must be equal to what? N2 V2. N1 V1 must be equal to N2 V2. Keep in mind. Next one. Now, if you are given sometimes volume in ml, suppose volume in ml you are given, then what to do? Next formula, what we have to take here? Volume in ml means N1 into V1 in ml, divided by 1000 we have to take. Okay, here also what we take? Normality of substance into volume of the substance, normality of the second reactant, into volume of second reactant in ml. Volume of second reactant in ml by what? 1000. Volume in ml by 1000 will give volume in liters only, na? So volume in ml by 1000 will give what? Volume in liters. So like this we can take. Most of the problems volume will be given in milliliters only. So number of equivalents of first substance reacted is equal to the number of equivalents of second substance. This formula we have taken. And instead of what normality, sometimes molarity will be given. When molarity is given, what we have to take? When molarity is given, what we have to understand concept? We have to take what now here? M1. Okay, in place of N1, what we can take? M1 into N factor of first one. M1 into N factor of first one. So what we have to take here? Molarity of first one into N factor of first reactant, into volume in liters. Otherwise, volume in ml by 1000. Volume in ml by 1000 we can take, or volume in liters we can take. So we have to convert volume into liters. That's all. Remember. So M1 is molarity of first reactant into N factor of first reactant, into volume in liters. Why we have taken this one? The normality N1 is equal to what? Normality N1 is equal to what? Molarity into N factor. Normality is equal to what? Molarity into N factor we have taken. So here again, the same thing how to take. If normality of second reactant is considered, what we take in place of M2 molarity of second reactant into what? Next what? N factor of second reactant into volume in liters. So this M2 into N factor of second one, M2 molarity of second reactant into N factor of second reactant, is what now? Normality of second reactant into volume of second reactant in liters. Is that clear, ma? So any formula for anything we can take this one. For any any type of reaction between two reactants, the same concept must be used here. We have to equate. Sometimes normality will be given, sometimes volume will be given liters, sometimes volume will be given in ml, sometimes molarity will be given, and N factor we must know for the substance. Like this, we have to convert. Next one. So it is M1 N factor into volume of first reactant in liters. Is that clear, ma? Next one, number of equivalents. Formula what now here? Another formula what we can use in place of N1, the formula for normality we have to use. In place of M1, the formula for molarity we have to take. Suppose you take N1. N1 means normality of first one, normality of first reactant. Tell me for normality formula what now generally? Weight by gram equivalent weight of solute by gram equivalent weight of solute into 1000 by what? Volume in ml. So this formula also we can apply now. So normality, how to calculate now? Normality is equal to weight by gram equivalent weight into 1000 by volume in ml. So this normality formula we can use here. Here instead of N1 directly will not be given sometimes. Instead of giving N1, they give you like this here. The weight of substance will be given, weight of solute will be given. Gram equivalent weight we have to understand for the given substance, and volume in ml will be given. Then we have to take what now here? This formula. After taking this formula, we'll get normality. That normality will be taken as N1. After taking normality as N1, into V1 in liters we have taken. If you want to get number of equivalents of first reactant, normality first we have to calculate like this. This formula used and calculated N1. After that, the volume should be taken in what? Liters only. N1 into normality of first reactant into volume in liters only we have taken. Suppose if volume is used in ml here, to get normality we have used volume in ml in this formula. After that, this volume should be converted into liters and taken here. So whatever we get N1 value from this formula into V1 in liters will be giving what? Number of equivalents of the substance. Is that clear, ma? So like this we have taken. Now we are taking number of equivalents. Remember, number of equivalents. Number of equivalents formula what? Normality into volume in liters. If you take number of milli equivalents, if you take, it will be volume in ml. Normality into volume in ml will be giving number of milli equivalents. Okay. And tell me now, sometimes molarity is used here. When molarity is used, tell me what we have to do, which formula we have to use. The same way, we have to take molarity. Molarity is equal to what? Weight of solute by gram molecular weight here. Remember, not gram equivalent weight. Gram molecular. Here we have to use what? Gram equivalent weight in normality. So weight by gram equivalent weight into 1000 by volume in what? Ml. Volume in ml, milliliters. So weight by gram molecular weight into 1000 by volume in ml will give molarity. So like this, molarity we can use here. Molarity we can get here. So in place of M1, if you want to calculate M1, we have to substitute the values of first reactant. If you want to get the M2, we have to substitute the values of reactant 2. Then we get molarity values. So molarity we can use this formula, and normality we can use this formula. Is that clear? So like this, by using these formulae, we can calculate what now? We can calculate molarity and we can calculate normality. Normality of first reactant or second reactant. Molarity of first reactant or second reactant. So what is given in the problem, we have to clearly understand. The given values, if you understand, you can easily understand anything. What are the given values, you must understand. From given data, which formula to be applied, you have to use your brain. Okay, so your brain should be using what? Artificial intelligence or natural intelligence. Your brain is having natural intelligence. That intelligence should be used here to solve the problems. What are the given numerical values, and what is to calculate, and what formula to be applied. For each one, many formula will be there. Suppose number of equivalents, we have different formula. Which formula to be applied, your brain should take. Okay, if you practice, you'll get it. Okay, need not to practice always the unknown problems from material. First, you take one reference book. In any one standard reference book, some solved examples will be there. The solved examples you have to go through first. If you go through solved examples, you'll get some idea how to solve. Then the unknown problems from material or from any other material, you have to do it. Okay. So please first practice solved examples of any reference book what you're having, or in the net also will be available. The solved examples on normality. If you type, you will get many problems. The solved examples of molarity. If you type, you will get many problems. So like this, make use of internet for useful purpose only. For solving the problems, you can get it. And if you type the given problem in the material, one problem is there. That problem, if you type in the Google search engine, within typing half of the problem, you'll get the solutions from different types of topper learning, from Brainly, from Merit Nation. You'll be getting. So don't go to Merit Nation, but go through Topper. TOPPR will be there. TOPPR, Topper and Brainly. These two will be given solutions directly. Because Merit Nation, they will ask you to download the app and it will take time, waste of time. Okay, so these different types of formula we have to use here. So we have used what now here. The concept is to be understood what now here. Number of equivalents of first reactant consumed in the reaction must be equal to number of equivalents of second reactant. And remember that whenever they give you molarity and all, first convert the molarity into normality only. After converting normality of the substance into volume in liters will give number of equivalents. So remember that the number of equivalents of first reactant must be equal to number of equivalents of second reactant. Okay, but number of moles, if you take number of moles of first reactant and number of moles of second reactant, these two may or may not be equal. Remember, that is always not correct. Okay, number of moles of first reactant may or may not be equal to number of moles of second reactant. Sometimes equal, sometimes not equal. So that concept we should not take. We should only take what now here? Number of equivalents of first reactant must be equal to number of equivalents of second reactant. That's all. Is that clear, ma? So this formula, this concept should be understood. Once take the screenshot of this. Take screenshot. Yeah, now next one. Now the continuation I'm taking again. Suppose I'm taking here what? The same. Reactant 1, R1, reactant 2, R2. Reactant 2, R2. Now here, in this case, what I'm taking is that, see, M1, V1 by N1. M1, V1 by N1 is equal to M2, V2 by N2. Here, N1, N2 are not N factors, remember. N1, N2 are not N factors. What are N1, N2 here? N1 and N2 are what? Number of moles in balanced chemical equation. Number of moles in balanced equation. In balanced chemical equation, number of moles of reactants. Number of moles of what? Reactants. The two reactants taken, for the two reactants, there will be number of moles. Okay, some X number of moles of reactant 1 reacts with what? Y number of moles of reactant 2. That number of moles of reactants will be what now here? N1 and N2. N1 is number of moles of first reactant in the balanced equation. N2 is number of moles of second reactant in the balanced equation. This number of moles called what? Stoichiometric coefficients. What are they called? Stoichiometric coefficients. Stoichiometric coefficients we say here. Stoichiometric coefficients or number of moles we say here. N1 and N2. Don't confuse with the N factor here. It is not N factor. Molarity of first reactant into volume of first reactant by number of moles of first reactant in the balanced equation. And M2 is the molarity, V2 is volume, and N2 number of moles of second reactant. And if you take this volume V1 in liters, suppose this V2 also to be taken liters. If you take V1 value, in ml, this V2 also take ml. That's all. Okay. This V1, V2 should be in same units. V1 and V2 should be in same units. What is condition? V1 and V2 should be in the same units. They should be in same units. Remember this point. They should be in the same units and the same formula to be used here. M1 V1 by N1 is equal to M2 V2 by N2. This formula we can use. Or we can also take number of milli equivalents. Number of milli equivalents of what? First reactant consumed is equal to what? Number of milli equivalents of second reactant. Number of equivalents we can take, number of milli equivalents we can take, anything. Okay, so the number of milli equivalents formula what again? N1 into V1 in ml. V1 in ml. That means what? Normality of first reactant into volume of first reactant in milliliters. And here what we take now? Here what we take is equal to N2 into V2 in ml. V2 in ml. So volume in ml should be taken here. Again, place of N1, what we can take formula? N1 place molarity of first one into N factor now. Here we are taking N factor now. N factor means valency factor into volume in ml. Volume in ml. Here what we take? In place of N2, what we take? Molarity of second reactant into N factor of second reactant. N factor of second reactant into what? Volume of second reactant in milliliters. Okay. So this molarity into N factor is what now? N1 here. In this case, N1 is equal to what? Molarity into N factor. Here also, molarity of second reactant into N factor is equal to what? Normality of second reactant. Like this. Is that clear? So like this, we have to understand the concept here. So what is given, what is to calculate? Whether volume is given in milliliters or whether volume is given in liters. Okay. So whether normality is given or molarity is given. So this concept should be understood here. From given data, we have to use the different formulae. Okay. So it is one concept here. Next, what here? Mole fraction. Some of students are asking doubts about what mole fraction. So in that case, what we have to take here? Suppose X2. X2 means mole fraction of what? Solute. Mole fraction of solute. So mole fraction of solute is given what? Given by formula X2 is equal to, mole fraction is given by X2 is equal to number of moles of second reactant by number of moles of first reactant plus number of moles of solute by number of moles of solvent plus number of moles of solute. Number of moles of solute by what? Number of moles of solvent plus solute. It will be X2. Now again, formula, tell me here, what is the formula for N2? Weight by weight of what here? Solute by gram molecular weight of solute divided by N1 is what? Weight of solvent by gram molecular weight of solvent plus again N2 na here. N2 means again weight of solute by gram molecular weight of solute. Okay. Now sometimes here this weight of solvent will be asked here. Weight of solvent will be asked. Mole fraction will be given. Suppose mole fraction is given 0.6. Mole fraction is given 0.6. And weight of substance is given, suppose here 4 grams. Okay. Gram molecular weight of substance is 40, suppose NaOH. Now weight of solid is given, gram molecular weight is given. So here weight of solid 40, gram molecular weight 40. 4 and 4 by 40 here also. 4 by 40, 4 by 40. Here weight of water they ask here. Weight of water they ask. Gram molecular weight of water we know 18. For H2O, gram molecular weight we know this one. So this substance NaOH is dissolved in water, suppose. In that case, water will be solvent, NaOH is solute. So now what we are taking, X2 is equal to 0.6 mole fraction given in the problem. And suppose weight of solute is given, molecular weight is known for the given substance. Then solution means water only should be taken as solvent. Then gram molecular weight of solvent 18 we know. Then weight of water they ask. This one we have to calculate. Okay, calculation part you have to do. Is that clear? So this is based on this, some problems, some students ask doubts. Okay. So like this, how many problems you can do on your own, that problems you do it. Need not to get worried about anything. I asked only the basic level problems to test you, whether the formula can be applied by you or not, whether you are able to apply the formula to calculate the numerical problems or not. That only I gave you. To solve the numerical problems, whether you are able to apply the appropriate formula or not. And simple calculations only I gave you. So need not to worry about that. Okay. So these all the formulae write on the same paper. Today what you'll do is that take one white paper and write all the formulae of solutions. Okay, together. All the formulae. W by W percent, W by V percent, V by V percentage. Okay, then molarity, molality, normality, ppm, ppb. Okay, so any formula, whatever we have discussed, all the formulae. Take any one reference book, that's all. One reference book you take and read from beginning of solutions up to the concentration methods. Okay, methods of expressing concentrations of solutions. Okay, and Henry's law concept, what I told you, theory part you concentrate. Theory part you concentrate on Henry's law. Numerical problems based on Henry's law in material don't do now. That we will do next week. Okay, is that clear, ma? Okay, so prepare well. Do not waste time. Okay, all the best.